Yeah, today we need to recap those things regarding that collection framework because
Please
I have left things.
screen
Okay.
share the screen.
Now,
Your screen is not visible.
now.
Ah, yes, sir.
Okay. Today we need to recap those things regarding that collection frameworks because of some things are left actually. So we'll cover those things here. Okay, we need to wait for 2 minutes. Yeah, hi, good evening. So today we need to learn regarding that what are the collections and why do we need that collections. Okay, basically the collections are the tool in the Java to store the and manage the group of objects like list of names or set of unique numbers. Okay, so basically why we need that collections are and why it's better than array. So we have using array, so why it's needed actually the collections. Okay, the basically the arrays and collections are both fundamental data structure only. Okay, for user to like store the group of data, but the collection the offer the several advantages on over the arrays, we can say. For especially when it comes to the flexible, it's easy to use and performance in certain scenarios, we can say. For the suppose, if you can see that in the dynamic size. Okay, in the dynamic size, the array we can say it's a fixed size. Okay, in the most programming languages including Java also, the array have the fixed size once they have created, like when you define an array, so you specify its a size. Okay, this cannot be changed after creation. For example, you can think like if you create an array as a 5 element, like suppose if you create an array, if you create an array of 5 element, so you cannot add and remove the elements after array is initiated. Okay, so this is the leads to inefficiency in if the size of the data changes dynamically during the program execution. So for that thing, so we are choosing that collection. In the collection, so in the dynamic size we can see that the collections such as that array list and hash set and linked list, etc, etc. Okay, and basically can grow the dynamically based on the number of an elements they hold. Okay, and basically if you add the more element, the collection automatically resize the to accommodate the new elements, we can say. The similarly the elements can be removed and the collection the like grow accordingly, we can say. Okay, for the example, we can say like in Java the array list automatically grows as the add more elements, and the size of the collection adapt without any without you have in any manual adjust. Okay, so last class we have seen that array list and sorry array list and that integer. So because we are storing the int only, so that thing we have the integer. So reference name is the list and name array list. Okay, so this is like basically here we can define the array list like this. Okay, suppose if you want to add the new elements, the basically here the array list it's automatically resized when adding the new elements. Okay, so we can add the numbers like list dot add one and list add list dot add, it's a tool like that. Okay, so if you want to remove, then we can use that list dot remove. So basically these add and remove keywords are reserved. Okay, here the collection that for this thing the collection goes automatically when the removing the element. Okay, so this is regarding that like why the collection is better than array. Okay, so we need to know the importance of the interface in the collection. 1 minute. Okay, so the interface for the collection. So basically the Java collection are the built around these key interfaces. The keys interfaces like the list, and the set and queue and the map. Okay, so basically the list means here we can see that for order the data where duplicates are allowed. Okay, for example we can see that the two things. Okay, here the array list and linked list. Okay, and in the set, okay, so basically for storing the unique element, like unique elements or unique items. Okay, like you can say like unique IDs also. Okay, for example you can say that has set or tree set. Okay, so in the queue, the basically the queue for storing the items in the order, they need to be a process like a line of customers we can say. Okay, for that thing, so for example I can say like a priority queue, priority queue, and next thing it's an array dq. Okay, and last thing it's a map. Basically for storing the key value pairs, like the phone number, like where the each names has number like that. Okay, for example here we can see the hash number, like hash map and tree map. Okay, so yeah, so these are the things regarding the interface. So now we need to understand the basic data structure and their uses. Okay, so we can say that key collection types in Java, the list, set, queue, map. Okay, so now we can see regarding the list. Okay, the list. Okay, so basically the list is an order collection that allowed the duplicates element, and it's ideal for the scenario where where the order of items is important, like to do list. Okay, for example I can take that array list. Okay, that array list. Okay, so the in the array list, this is the best for the fast searching and random accessing. Okay, this is for your interview will ask regarding this why array list is better. Okay, so you can say regarding that best for the fast searching and random access. Okay, so if you need to quickly find or access an item by position in the list, the array list is very efficient. This is because it's used like array internally, and where each item has an index. Okay, so backed by the dynamic array, so an array list is a built on the top of the dynamic array, unlike regular arrays. Okay, then it can grow in size automatically, and if you add more items then it can currently hold, so it will create a larger array to accommodate all the items. Okay, and basically we can say like the list was slower for inserting and removing the items in the middle. So basically the interviewer asked regarding the demerit, so then you can say the for slower for inserting the element or removing the elements. Okay, and yeah, so when you add and remove the items in the middle of the list, okay, the all the items after the position need to be shifted to the to make a space, or we need to fill the gap actually. Okay, the shifting process take extra time. Okay, the making these operations slower compared to the structure like array, like linked list we can say. Okay, so in the next part we can see regarding the linked list. Okay, so for the linked list we can see that efficient for the inserting and removing the items in the middle of the linked list. Okay, in the array list we can see that slower for the inserting and removing element. In the linked list basically it's efficient for the efficient efficient for inserting and removing in the middle of the list. Okay, so here in the linked list is the great when you frequently add or remove items from the middle of the list, the unlike the array list. So it does not need the shift items around the, because it makes up the of node actually that are linked to together. So here we can say one more thing regarding the doubly linked list. Okay, the linked list uses a data structure called a double linked list. The each item in the list contains data and the two links. The one is the pointing to the previous node and one is pointing to the next node. Okay, so this structure makes easy to add and remove nodes. For that thing, the linked list is the efficiency for inserting and removing the middle of the list. Okay, but here you can see the, yeah, here the slower for the slow one. Okay, slower for the searching, because of it requires traversal. Okay, in the array list you can see the slower for inserting and removing, and the linked list you can see the slower for searching. Okay, because of here we need the traversal in the linked list, but here in the linked list we are using the node wise. Okay, to find an item in the linked list you have to start from the beginning and move through the each node one by one until you find the what you looking for. Okay, that this process takes more time compared to array list, so which can directly access by their position. Okay, so we can define that linked list like, so we can define the list. Okay, then here we need to add that string data type, and here we can linked list and new linked list. Okay, suppose if you want to add the items, so then you have to do the linked list dot add and after the node 1. Okay, so if you want to, yeah, If you want to print, then you have to check that linked list reference. So you will see one array. In that array you will see those nodes actually. Okay, this is regarding that linked list problem. So next thing we can see regarding that a set. Okay, the set. The set. Okay, so in the set basically, here we can say that ensure that all the elements are unique. Okay, the set is the collection where the duplicates elements are not allowed. Okay, and it automatically ensures that every items in the collection is unique, and making it the perfect for case every like where repetitions are not allowed. Okay, such as the storing the student IDs or unique inventory items we can say. So basically when to use this one. So suppose you can use this set when you want to keep the only unique elements. Okay, you don't care about that order in which they are, like in which they are stored actually. For example, uh, 1 minute, here duplicates are not allowed. Duplicates are not allowed. Okay, for example, we can see example, we can see this hash set. Okay, basically the hash set is the best for the fast operation like adding, removing, and checking the if the items are exist, and does not maintain that any order of the elements we can say. Okay, and here we can see that tree set also. Okay, so tree set basically it's to keep the element in the sorted order. Okay, and here we can see that tree set is the slightly slower than the hash set due to the sorting overhead we can say. Okay, and here we can see the one more thing regarding that linked hash set. Okay, in the linked hash set basically here the maintain the insertion of the order of elements, and basically you can say that it's useful when you need unique elements and like want to preserve their order of addition we can say. Okay, for example, for hash set, uh, 1 minute. Hash set. So basically here the hash set offers the fast operations like add, remove, and search. Okay, and basically we can say it's a backed by hash table. Okay, so we can define, like we can initialize that hash set like this. We'll write the string hash set set. Okay, we can define like this. Okay, so now here we can add like same thing. We need to use those keywords like add hash set dot add id 1. Okay, same thing we need to add one more items. id 2. We can print system dot out dot println. Okay, we need to print that reference. So this is example for a hash set. Suppose if you want the example for the tree set, so we have to change that particular hash set. Instead of hash set, we have to add that a tree set. Basically, a tree set is keeps the elements sorted in the natural order by custom comparator, we can say. Okay, and basically the tree set the slower than the hash set, but it's useful the when sorted data is required. Okay, so this is regarding that hash set and hash tree set. The hash set is very important, okay, during solving the optimized problems. Okay, the third thing we can see regarding that queue. Okay, so basically the queue it's represent the waiting line, we can say, first in first out, like that. Okay, the basically the queue is the collection where the element are they processed in the order they were added. Okay, just like line of people's waiting for service, and the first person to enter the line in is the first to be served, like we can say FIFO, first in first out, first in first out, first in first out. So we can see for the queue. Okay, so here we can see the queue is the collection where the elements are processed in the order they were added, just like the line of people waiting for services. Okay, the first person to enter the line is the first to be served. So like that, the first in first out. So basically when to use this one, so we need to use this queue when you need to process the item in the order they were added, such as handling the task in the task manager, the process the customer request, and managing the data streams. So there we can use this queue actually. Okay, for example, we can see that 1 minute I will write those things. For example, we can see the priority, like priority queue. Okay, so the priority queues, here we can see the items are processed based on the priority rather than the order they were added. Okay, and one more thing we can say here, that it's the highest priority items is processed first. Okay, and the making it useful for scheduling the tasks and events in the system, we can say. Okay, here we can see the one more thing, it's a linked list. Okay, so basically linked list we can use it as the queue. Okay, the linked list can be used as a queue where the elements are added at the end and removed from the front. Okay, and it's efficient for the adding and removing the item from the both end of the list. Okay, and one more thing we can see, it's a array dq. Okay, so in the array dq, the dq in the sense is a double-ended queue. dq in the sense is double-ended queue. Okay, so the dq can function as the regular queue and allow the adding and removing the element from the both ends of the collection, so making it possible, like a flexible option, we can say. For example, we can see for priority queue. So for the defining queue, need to use that queue, and here I'm adding that integer type, and here we can priority. This is our reference creating on the instance. Priority queue. Okay, so here also same thing, so we need to use those reserved keyword like add. Okay, the priority queue and add. Okay, so we can print like system dot out dot println the priority queue. So this is for priority queue example. Okay, so yeah, it's basically priority based problem. And next thing we can see regarding that map, the map. Okay, the basically the map we can store as a key value pair. Okay, the key value pair in the sense the name, sorry, okay, name is the key, value means your name actually, like, yeah, whatever you can add, like, is the plain code. So this name we can say as the key, and this name, that clean code, we can say it's the value. Okay, a map is the collection of store the data in the form of key and value pairs. Okay, so each key is associated with a specific value, like meaning that you can retrieve the value by referencing the key. So if you want to print that particular value, then you can, using the key, you can print those things. Okay, so it's like the dictionary where each word as a key maps to the definition, like definition in the sense of value, that, yeah. And basically when to use this one actually, so we need to use the map when you need a store, like when you need to store the data where each piece of information has a unique identifier. The unique identifier in the sense it's a key. Okay, and if like you want to like quickly look up and update and remove the data using the key, so common use case including the creating the phone book, we can say. In the phone book you can see that name to phone, like name to phone number as a mapping. Okay, or you can see that address book. Okay, email to contact info, like that. So here we can see some examples in the map. Okay, in the first thing you can set the hash map, the hash map. Okay, the hash map basically we can say it's the best for the fast looking up the insertion and deletion part. Okay, and here like does not maintain that order of elements. Okay, and here one more example we can see the tree map. Okay, in the tree map basically we can say that it keeps the keys in the sorted order in the key in the tree maps. And basically the tree map is slower than the hash map due to the sorting overhead, but it's useful when you need the ordered keys actually. And one more example you can see the linked hash map, the linked hash map. Okay, here we can see that here the maintain the order of the element based on the order of they were added actually. Okay, for useful when you like when you want to store the key value player and maintain the insertion order. For that thing we can use that linked hash map. Okay, for example for the hash map you can write hash map. Okay, so for the defining the that like creating the instance we can use this map. Okay, so here we need the key value player in the sense here we need to add this one. This is for the key string, this is for the key, and this is for the value string. Okay, hash map new, the hash map. So here we need to use, instead of that add, we need to use some put hash map that dot, we need to use the put reserved keyword. Okay, so here we can use the name is the Ramesh. Okay, his id is the, we can say it's a 12345. Okay, so like this we can adding those key and value pairs. Okay, system dot out dot println, this we need to print. Okay, so here you can see the one object, in that object you can see that Ramesh, okay, equal to 12334. Okay, in the same thing in the tree map, basically it's a keep the key stored in the natural order or by customer comparator. Okay, and basically it's the tree map, it's slower than hash map. Okay, and here we need to use that here also we need to use that put instead of that add. Okay, so we can see some problems actually regarding. So before that we need to know the summary of the operations. The operations. Okay, for list, like we are using for the add, the remove, and search for the items. Okay, and for the set, for the add unique items, and third thing, it's a queue. This is for add the items and process them in order. And fourth thing, it's a map. Okay, we need to store and retrieve the key value pairs. Store and retrieve the key value pairs. So these are the operations we can see regarding that collections. Okay, so now we need to solve some problems regarding that array list and linked list, and regarding that set queue map. Okay, so are you guys understand regarding that list set map queue? Am I
Yes, sir.
audible? Am I audible?
Yes, sir.
What about Priyanka?
Yes, sir.
Okay, so we'll do some problems. Okay, okay, the first scenario problem, the scenario is the management, like managing the wait list for the restaurant. Okay, managing for the wait list for the restaurant. Okay, so here we need to use, that array list. Okay, so if the restaurant wants to frequent access the nth number, like nth person on the wait list, like for example you can think like who is the fifth person waiting, like that. Okay, and the array list is the best like better choice we can say. So this is because it allows the fast random access to any person in the list. Okay, for that thing we took that array list. Okay, so we need to do for program. So here before that we need to import two things. One, it's a import java dot util the array list. Okay, and second thing, import java dot util list. Okay, and here we need to create an instance for the list. Okay, the list, and here I'm storing the string. Okay, the string, and here the wait list. Wait list, the new keyword, then array list. Okay, so here we need to add the customer to the wait list. Okay, so here we need to add the customer to the wait list. Here the wait list, add the first customer, I can say it's a Kaustubh. The second customer, we can say it's a Yuvraj, and third customer we can say it's a Priyanka. Okay, so suppose here if you want to access, okay, here if you want to accessing the second person on the wait list, okay, for that thing, so we can choose the index 1. Okay, in the index 0, so we can see for the Kaustubh, but we need the second person Yuvraj. Okay, for that thing we need to accessing the second person on the wait list, we need to check that index 1. So for that thing we need to print that this is the second person, this is second person wait list. For getting like for printing the names, so we have some keywords, the get method, so we need to use that get method for getting the items. Okay, we have the get keyword, we have to use. Okay, then so we need to run this program actually. Yeah, you can see our second person is the Yuvraj. Okay, the same thing we have to use as a linked list. Okay, so in the linked list we can say if the restaurant needs to quickly add and remove customer from the middle of the wait list, for example the prioritizing the VIP or handling the cancellation, the linked list is a better choice. Okay, and this is because the no shifting of elements is required, the only the links between the nodes are updated. Okay, for that thing, so we can use, so this is for the array list. Okay, so here the same thing we have to define that linked list. Okay, here we need to add the customer to the wait list, so we have already added those customers here, the Kaustubh, Yuvraj and Priyanka, and here we need to check, like we need to adding the VIP customer to second position. Okay, what is our second position? This Yuvraj is the second position. Okay, here we need to add that VIP customer. Okay, we don't know who is the VIP customer. Okay, in the yeah, here we need to add for the adding the VIP customer, the wait list dot add. So first index, in the sense we have to give that first index and we have to add that VIP index, like VIP customer. Okay, and if you want to remove, so you have some remove methods also, and you can remove those things also. Okay, so here we can see this. Okay, updated list is wait list. This is the updated, we can mark updated. Okay, now we can check the output. What is the linked list? We need to import the linked list. Okay, so here you can see we need to, like here we added that VIP customer for the second position. Okay, so in array list and other operations you can't do easily, but you can do easily in the linked list, because here we can see the node wise. And if you want to remove the, like if you want to remove the elements, so then you have to use like wait list dot remove, use the remove method, and use that particular name, and you can check the updated list. You can see that Kaustubh and VIP customer and Priyanka. So this is our updated list. So this is regarding that linked list. Okay, so these are the two things we can see regarding the array list basically when the fast access to items by index is needed, and for the linked list when the frequent insertion and removal in the middle of the list are expected, we can say. Okay, these two are the main reason for the array list and linked list. The interviewer asked regarding the difference between the array list and linked list. Okay, so next thing we need to we need to do the problem regarding the hash set and tree set and linked hash set. Okay, so here this is done. So now we can take one scenario regarding the managing the unique student IDs. Okay, student IDs. So imagine a university system where the student IDs are need to be managed. Okay, so for that thing, so we have the three operations like a hash set, tree set, and linked hash set. Okay, the hash set and tree set and the linked hash set. Okay, so basically like in the hash set, when you when the system is needed to ensure the like student IDs are unique but does not care about the order. For that thing, so we can use that particular hash set. Suppose when the system needs to ensure the student IDs are unique and also the maintain them is sorted order. So for that thing, so we can use the tree set. Suppose when the system are needed to ensure that student ID are the unique while maintaining the order in the which they were added. For that thing, so we can say that linked hash set. Okay, so we can do like code for hash set. Okay, so before that we have to import the hash set here, and instead of list we need to use the set. Okay, so here we need to use the set instead of list. The hash set, change that reference also, student ID. Okay, so here we need to add the student IDs. Okay, I'm trying to add the duplicate also, the student ID dot add here S123. Okay, here I can see that 2, 4, okay, and 3. So I will print this one. Okay, so we have the like the student unique IDs S2124 and S125 and S122 and S123. Okay, so I will try to add that same number, like same here, student ID here. Okay, you can see this is our output, but here the input you can see the 2 times of the S125 because of the duplicates will not be added. Okay, so this is our final update, we can say. Okay, and the same thing for the tree set. Okay, for the same thing in the tree set we will try. You need to import the tree set. Here basically the best for the tree set when you need IDs to remain sorted for reporting like reporting or lookup purpose, we can say. So here the set and tree set. Okay, so we need to use the tree set, and here the set and the student ID. Yeah, so basically here regarding that tree set. Okay, so yeah, this is best for when you need that IDs remain so sorted for reporting purpose. Okay, so the next thing we can see the linked list, like linked has a set. So here we can say for the best for when you need to maintain the insertions order for tracking the purpose. The same thing we need to change the linked hash set actually here. Okay, I will see linked hash set. Yeah, so this is regarding the linked hash set. Okay, so here we can see the hash set is a fast operation but no guarantee of the order. Okay, and the tree set, so we can see the maintaining the sorted order but it's slower than hash set. The both are performing same, but just thing is the slower than hash set. And in the linked hash set, so we can see the maintain that insertion order while ensuring the uniqueness. Okay, the set is basically for avoiding the duplicates values and duplicate items. Okay, and the next thing we can see regarding the queue. Okay, so for that things we can take the scenario the handling the ticket systems or ticketing, yeah, ticketing system. Okay, so imagine a system for movie theater like that handle. Okay, in the regular ticket queues the people are served in the order they arrive, means the first in first out. Okay, the second thing, the priority ticket queue, means here VIP customer are served first regardless of their arrival time. And third thing we can say is a flexible queue, means allow the adding and removing the ticket from the both ends of the queues for the dynamic scenario. Okay, the first thing is the regular ticket queue. Ticket queue in the sense the first in first out. Okay, and second thing it's a priority ticket queue. Priority ticket queue. So here we can see that VIP customers are served first and regardless of their arrival time. Okay, and third thing, flexible queue. Flexible queue. So here the allow that adding and removing the tickets from the both ends of the queue for the dynamic scenario, we can say. Okay, for example, for the we can use that linked list as a regular queue. Okay, so here we'll do for code for linked list. Okay, so here I'm importing the linked list, and here I'm using the queue, and here we need to change from set to queue. Okay, here I'm changing that linked list. Linked list. Okay, so here we are trying to add the regular queues. Okay, change the reference name, regular queues. Okay, the regular queue we need to add regular queue. Add first in the 1, and second thing it's a 2, and third thing it's a 4. Right, 2, 3, 4. Okay, so here we are like we here the adding the customer to the queue. We have added the customer 1, 2, 3, 4. Okay, so we need to print. Okay, we need to print serving the customers in the first order. Here we need to print the serving the customer in the first order. Okay, the first thing I am here adding the serving. Okay, serving. Here I will take that reference, and we have some methods. The method's name is a poll. Okay, so here I am checking, and the serving output is the, you can see here. Yeah, right now serving like service like the serving is the 1. Okay, and I will add one more print regarding that regular queue only. Okay, so right now this one is serving, remaining peoples are queue in the queue. So we need to check these peoples are queue or somewhere actually. Okay, so we'll check here. So regular, here you can see that one is not printing because of here that one is serving in this poll. We need to use that remaining queue. Remaining queue. Sorry. Remaining queue. So here the serving the customer in the first out order. Here the serving the first one here. Okay, remaining 3 are like here like queuing in the separate order. Okay, so this is regarding that first thing, that regular ticket queue, first in first out. Okay, and second thing we need to use that a priority queue for the VIP tickets. Okay, so for that thing we have to import that priority queue. Priority queue, need to import, add. Okay, so here I can change that name to VIP queue. We need to add, add that integer, that 1, 2, not 4, 6, 3. Okay, so now here I will print basically here like the adding the VIP tickets holder. Okay, and here 1 minute I will add here 9. Okay, so now I need to print, okay, the serving tickets based on the priority. Okay, so here I will add the serving VIP with priority, VIP with priority. Okay, here I will add that VIP queue dot all. Okay, so here we can see the first one in the sense that like we'll see this one. Okay, the 3 and the remaining VIP queues we can see, can run this problem. Yeah, see here, first queue 3 is the first thing. So here like the best, here we can say it's the best processing ticket where the priority matters. Okay, not arrival the orders, just matters here the when, like where the priority matters, is not they taking the order. Okay, so here the 3 is our last. Okay, for that thing here taking the first one, it's a 3. Okay, and the third thing, so array DQ. Okay, so basically array DQ, like using the array DQ for the flexible queue. Okay, here we can say it's the best for the handling the tickets with flexible addition and removable, like removal that either end actually. Okay, so we can do for DQ, so we need to import the DQ. We need to import the array DQ, array DQ. So here we need to store the string values, and we need to store the like flexible queue. So I am changing that reference name also, flexible queue. Okay, I'm changing the priority queue to the array DQ. So here I'm changing this one. So in the array DQ, so we can we have the methods called array, like add last. So we can add the element at the last also. So we'll check that one. Last. Okay. So here ticket 1. Okay, ticket 1, and here ticket 2. And so we have one more method called that add first, so we can here use that one, the add first. So here we can say this one, it's a VIP ticket, okay. So these two are, we can say, for the add to the n, and this one we can say for the add to the front. Okay, now we need to serve the tickets. Okay, so first thing I'm serving the first ticket here, the flexible queue, dot poll first. Okay, so here you can see the only VIP ticket will print, because of here we are checking the poll first only. 1 minute, so we need to add that D. here we need to, like, we can see that particular the serving is the VIP ticket because of, so we are checking the Paul first. So here you can see the Paul first is the VIP ticket. Okay, so we need to check the remaining queue also. The remaining queue, the remaining queues are ticket 1 and ticket 2. The VIP ticket is serving right now because of we are reaching the Paul first. Okay, so here the linked list in the queue, the linked list is ideal for the simple first in first out processing. And the priority queue, so here it's perfect when the items need to be served based on the priority. Okay, in the array DQ, basically it's best for the flexible operations where the items can added and removed from the both end. So you can see in the DQ, so we can add. I'm audible, no?
Yes, sir.
Okay. Okay, in the array DQ, you can see like the operations we can add in the front also and both also. Okay, here you can see that we have the methods called array, like add last and add first also. Okay, so this is regarding the queue. Okay, so now we need to check regarding the map. So map. Okay, so in the map we can take one scenario regarding the library system, managing the library system. Library system. Okay, so imagine the library system that tracks the books and their browsers. Okay, like the each book has the unique ID, means key, and the browser's name is the stored as a value. Okay, and the second thing we can see the sorted books by the title. Okay, the books are stored with their title as a key and their ID as the value in the sorted order. Okay, and yeah, sorry, yeah, borrowing the history, we can say it's a track the borrowing order, the like insert order we can say. Okay, so the first thing we can say regarding the hash map, so here we can check like fast access, the best for storing the books and borrowing the when the order does not matter. Okay, the first thing is the hash map. Okay, and second thing it's a tree map for the best storing the books in the sorted order by title. Okay, and third thing we can see regarding that linked hash map. Okay, so here we can see the best of the tracking of order of borrowing. Okay, so we can do code for that hash map. Okay, so we need to import that hash map here, that hash map, and we need to import that map also. Okay, so here for the map, so we need to use that key and value pair. For that thing we I'm using here the like the data types as a string, and for the key and value. Okay, so here I need to use the map instead of DQ. So here I'm checking the borrow like books here I need to change that hash map. Okay, so we need to add add the books and borrowers we can say. Okay, so here I can add the books dot put. Basically in the map we are using the put. Okay, yeah, for the add, like add actually. So in list set in the queue we are using that add, but here we have to use the put. Okay, so here I'm adding the books one. Okay, the books one, the borrowing person is the Yuvraj. And this, we have some other books also. The second book, the borrower name is the Preetham, and third book, the borrower name is the Priyanka. Okay, and fourth book, so borrower name is the Kaustubh. Okay, so we need to retrieve the borrower's book by by ID actually. So we need to print the book by IDs. Okay, suppose if I print that B1, so we need output as a Yuvraj. Suppose if I print that B4, I need that Kaustubh. So like that, so we need to retrieving the borrowers by the book ID. Okay, so here I will change that string borrower of B1 B2. Okay, so here I am checking the books dot get. So we have the get method, I'm using that one. Okay, so here I need to add that particular key. What is key? B2. Okay, here I need to check our output. The output should be the Preetham. Yeah, so borrower of B2 is Preetham. Okay, so we need to print all the entries actually. Okay, for that thing I am using here borrowed books. Need to print all the books detail here. Borrowed books. Okay, yeah. Here you can see there is an object. In the object you can see the key and value pair. Okay, so B2 is the key and Preetham is the value, B3 is the key and Priyanka is the value. So these are the things we can see in the key value pairs in the map. Okay, so this is regarding the hash map, best for the storing the book and borrower when the order does not matter. Okay, so the second thing, we need to use the tree map for sorted the book titles. Okay, here the best for the storing the books in sorted order by title. Okay, so we need to use that tree map here instead of the hash map. We need to import the tree map. Okay, and here we have already imported that map, and here we have that map, and we have to change the tree map instead of hash map. Okay, so here we have the books. Okay, so we need to add the books with the title as a key, ID as a value. now I'm changing. We don't need key as the id. Now I'm keeping the name as the key. Okay, so here our key is right now the name, like titles. Okay, these are the book titles, not a name. Okay, so we'll change the names. The jungle book, and second one it's the duck, and third thing is the 1992. It's a book. Okay, so here we need to printing the books in the sorted order by title. Okay, so here I will change the string also here. Books in sorted order. Okay, so here we like need to use that like reference. Yeah, you can see like here we are printing the books in the sorted order by title. Okay, the first will take the numerical, next it's the alphabetical. I can say it's a D, and third one we can say that one the T. Okay, here we are like that printing the books in the sorted order by title. Okay, so this is regarding the tree map. And next thing we can take regarding that linked hash map. Basically the linked hash map using like for the borrowing the history. Okay, and best for the tracking the order borrowing. Okay, so we can do code for the linked hash map. Okay, so we need to import that linked hash map here. So here I'm adding the books, okay, as they are borrowed. Okay, Hitam, the B2 as the Kaustubh, and third thing B3 as the Priyanka. Okay, so here I'm checking the borrowed history. Borrowing the history. So here I'm checking the book. Okay, the printing those things. So here you can see like we are checking the like the, the order of borrowing. Actually basically that linked hash map is best for the tracking the order borrowing. So here we are adding the books as they are borrowed. Okay, and here we are printing the borrowing history in the insertion order. And here you can see that object. Okay, key value pair. Okay, you can see the order wise the book like book stored as an order as here also. Okay, so this is regarding the collection part actually. So do you have any doubts regarding the collection? So regarding the list, map, tree, like yeah, the set and queue.
No, sir.
What about Priyanka?
No, sir.
Okay, I need to ask something. So, do you have any doubts regarding the OOPS concepts? Because that one is very important actually.
No, sir.
What about others? Sorry?
No, sir. No, sir.
Okay. Did you guys go through that GitHub? So, did you created the GitHub accounts and did you push those codes into the GitHub?
Yes, very well.
What about Priyanka? Are you able to push the code into the
Not
GitHub?
yet.
Okay. What about Preetham and Yuvraj and Kaustubh?
Yes, sir. We did.
Okay. Priyanka, are you facing issue in that?
No, sir.
So you can do tomorrow, okay?
Yes, sir.
Okay then. So you don't have any doubts means we can wrap up the session, okay? So I'm audible, no?
Yes, sir. Yes, sir.
Okay then. Thank you.
Okay, thanks. Good.